Voyager 1 just picked up a cosmic mystery, and it's blowing scientists' minds. More than 4 decades after its launch in 1977, Voyager 1, the most distant spacecraft ever built, is still rewriting the story of space. Now, billions of miles from Earth, beyond the edge of the planets, it's made a discovery that no one saw coming. The spacecraft is currently cruising through the heliopause, the invisible boundary where our sun's influence ends and interstellar space begins. Scientists used to think this area would be quiet, maybe even empty. But Voyager 1 has picked up something totally unexpected. A strange, steady hum. Not static, not noise, but a consistent low-frequency vibration. It's the sound of plasma waves, electrified gas particles, that seem to stretch across this mysterious zone. And here's the wild part. This hum doesn't seem to care what the sun is doing. It doesn't change with solar flares or solar wind, it just keeps going. Hit like and subscribe if you want to hear more stories from the edge of space. This discovery flips what we thought we knew about space outside our solar system. Instead of being silent and empty, the interstellar medium, the stuff between the stars, turns out to be subtly alive with movement and energy. Dust and gas drift there in extreme thinness, but still manage to pulse and vibrate under forces we're only beginning to understand. Even more incredible, Voyager 1 wasn't designed to detect this. Its instruments were meant to last 5 years, not nearly 50. And yet it's become a kind of cosmic ear, listening to a whispering universe from a place no other spacecraft has reached. For years, scientists pictured the heliopause as a sharp boundary, like the skin of a balloon. But Voyager's data suggests it's more like a mixing zone, a place where the solar system's edge and interstellar space tangle, blend, and perhaps even push back against each other. This steady plasma wave could be the first clue to a whole new layer of cosmic activity. It hints that space beyond the sun isn't just drifting dust. It may have structure, patterns, and maybe even its own rhythms, like a background beat of the galaxy. Could this hum help us map the unseen architecture of space? Maybe. Could it point to other forces at work in the universe? Possibly, but one thing's for sure. Voyager 1 has once again reminded us how much we still have to learn. Out there in the vast quiet, it's hearing something no one expected, and it might just be the start of a much bigger story. For years, scientists thought that once you left the solar system, space would become even colder, quieter, and more lifeless, a vast, empty stretch between stars. But Voyager 1 has proven otherwise. Instead of drifting into a silent void, the spacecraft is picking up a faint but steady hum, a low-frequency plasma vibration echoing through interstellar space. This discovery suggests that the cosmos beyond the heliopause, the outer shell of the sun's influence, is alive with subtle activity. It's not empty at all. It's a dynamic, textured realm, teeming with invisible motion. And that changes the game for future space missions. Rather than just aiming for distant stars, the next generation of spacecraft might be tasked with mapping the terrain between them. Interstellar space may not be a barren vacuum. It might be more like a vast cosmic ocean with its own currents, tides, and energy patterns. To explore it properly, we'll need instruments designed to listen to the plasma waves and decode the whispers of this unseen world. This discovery reshapes how we view deep space. It's not just about the planets or exoplanets anymore. The space between the stars is becoming a destination in its own right, rich with clues about the universe's structure, history, and forces we don't yet fully understand. And that ever-present hum Voyager 1 hears? It could be just one piece of a much larger symphony, each note revealing something new about the galaxy we call home. What's more, this plasma activity challenges how we see the heliosphere, the protective bubble formed by the sun's solar wind. We once imagined it as a solid boundary, but now it seems more porous and reactive, with interstellar forces possibly seeping in while solar particles quietly drift out. This has huge implications for how cosmic rays interact with our solar system, how magnetic fields behave at galactic boundaries, and even where some high-energy particles near Earth might come from. There's even speculation that these plasma waves could be linked to magnetic reconnection events, powerful phenomena where magnetic fields snap and rejoin, releasing bursts of energy. We've seen them near Earth and on the Sun, but Voyager 1 might be catching them at a galactic scale, out at the solar system's edge. What's truly astonishing is that none of this was planned. The engineers who launched Voyager 1 back in 1977 could never have predicted it would still be working nearly 50 years later, let alone detecting plasma waves billions of miles from home. The instruments weren't designed for this, and yet they're delivering discoveries that are reshaping astrophysics. Each signal Voyager 1 sends back is more than just data. It's a reminder that space isn't silent. It hums, it breathes, it moves. And while we've barely scratched the surface, these early findings may spark a new era of space science, one focused on understanding the hidden plasma web that connects our galaxy. The data will inspire fresh research, new spacecraft designs, and questions we haven't even thought to ask yet. Voyager 1 didn't just explore the outer planets, it has opened a door into a deeper, richer cosmos. A cosmos filled not just with stars and worlds, but with the mysterious substance between them. And as it continues to drift farther into the unknown, it carries with it the promise that the universe still holds secrets beyond imagination. The unknown isn't just some distant place we haven't reached, it's a layer of reality we're only beginning to notice. And Voyager 1. It's pulled back that cosmic curtain just a little. What's peeking through is both mesmerizing and mysterious. For decades, we imagined the edge of the solar system as a finish line. But Voyager has shown us it's more like a doorway, a transition zone teeming with surprises. Light, gravity, and motion have long been the ways the universe speaks to us. Now, Voyager 1 has revealed a new voice, plasma, a whisper in the dark, carrying secrets from interstellar space. As the spacecraft drifts farther into the unknown, it continues to listen. And through it, so do we. That persistent low-frequency hum it's detected isn't just strange, it's profound. It signals that space beyond our sun's reach is alive with subtle energy, full of dynamic interactions we've never seen up close. The deeper Voyager 1 goes, the more it's becoming clear. We're just scratching the surface of a galactic ocean that stretches far beyond what we thought possible. Right now, Voyager 1 is in a place no other human-made object has reached, a zone where the sun's protective bubble fades and the raw energy of the galaxy takes over. One of the biggest mysteries in this region is radiation, how it behaves when it's no longer filtered by the sun's magnetic field. For a long time, we believed the heliosphere shielded us from most of the galaxy's high-energy particles. But now, Voyager is out in the open, and it's detecting levels of radiation that are more intense and unpredictable than expected. This matters not just for science, but for the future of deep space exploration. If we're ever to send humans beyond the solar system, we'll need to know exactly what they'll be up against and how to protect them. Even the spacecraft's limited data is giving us our first real clues. But perhaps the biggest revelation is how this region helps us understand the structure of the galaxy itself. Voyager isn't just measuring particles, it's sensing the contours of our place in the Milky Way. It's helping us map out the galactic magnetic field, track the density of interstellar particles, and glimpse the invisible winds that sweep between the stars. And it turns out this space isn't uniform. It's full of subtle variations, hints that the interstellar medium may be far more complex than once thought. Could it be shaped by ancient supernovae, twisted by stellar winds, rippled by galactic tides? We don't know yet. But Voyager 1 is helping us ask the right questions, and that's the beauty of it all. This lone spacecraft, launched in 1977, is still teaching us, still surprising us, still reminding us that space isn't silent. It's singing a song we've only just begun to hear. Voyager 1 is beginning to resolve these mysteries by providing empirical data that can be cross-checked with simulations and theoretical models. For example, fluctuations in plasma density and magnetic field strength hint at the existence of boundaries within the interstellar medium itself, zones where different interstellar weather systems might interact or collide. These are not boundaries in the traditional sense, but gradients and contours in the galactic fabric. Another critical facet of Voyager 1's ongoing mission is its ability to detect variations in particle populations over time. Interstellar space is not static, and the spacecraft's instruments have shown that the environment fluctuates in a way that might correlate with galactic-scale processes. Perhaps it is responding to the broader rhythm of the Milky Way's rotation or the passage of shock waves from distant cataclysms. These correlations, while tentative, point toward a dynamic and reactive medium that is constantly evolving on both small and large scales. The existence of such variations opens a tantalizing possibility that Voyager 1 could eventually pass through regions of interstellar space vastly different from the one it currently inhabits. For example, it may enter a denser cloud of gas and dust, which could affect the readings on everything from particle density to magnetic field strength. These clouds, remnants of ancient stars and nurseries for new ones, populate the galaxy like islands in an ocean. Passing through one would offer a priceless opportunity to study its properties firsthand, an event that has never occurred in the history of space exploration. One of the more speculative but fascinating implications of this journey is its potential to test ideas about dark matter. While Voyager 1 was not built to detect dark matter directly, it travels through regions where gravitational influences might manifest in subtle ways. If the spacecraft were to detect anomalies in its trajectory, deviations not explained by known gravitational forces, it might hint at unseen mass in the surrounding space. This would not be evidence in the classical sense, but it could contribute data to a growing body of work aimed at mapping the unseen architecture of the galaxy. There is also a philosophical dimension to this odyssey. Voyager 1 is not simply extending humanity's reach into space, it is redefining the meaning of distance and connectivity. Even now, over 20 billion kilometers away, the spacecraft sends back data that takes more than 22 hours to reach Earth. Yet, this stream of information, delayed as it is, keeps humanity connected to the edge of its cosmic domain. Each bit of data is a physical link between the cradle of civilization and the great unknown. It's as if Voyager 1 is unraveling a cosmic thread that stretches back to Earth, guiding us deeper into a realm that no other living being has touched. As Voyager 1 sails deeper into uncharted territory, it's rewriting what we thought we knew about the boundaries of our solar system. The edge we once imagined as a hard line, a clear border between us and the rest of the galaxy, isn't a line at all. It's a hazy dynamic zone. The heliopause isn't a wall, it's a shifting threshold, alive with energy and unexpected interactions. The soft, persistent plasma hum Voyager hears is proof that even the most distant limits are more like doorways than barriers. And what makes this even more incredible, none of it was part of the original plan. Launched in 1977 with what we now consider vintage technology, Voyager 1 was never meant to explore interstellar space. Its instruments were built to study the planets, yet here it is, decades later, recording the hidden vibrations of deep space. That's the magic of smart design and scientific curiosity. Sometimes it's the unexpected data that changes everything. This serendipity sparks an important conversation for the future. Should our next deep space missions be more open-ended? Should we prioritize versatility and longevity over strict mission goals? Voyager 1 suggests the answer might be yes. Because space doesn't give up its secrets easily, it rewards patience, resilience, and a willingness to be surprised. Voyager 1 is also changing the way we think about talking to our machines across vast distances. Its signal is whisper quiet, barely reaching Earth after traveling over 20 billion kilometers. Capturing that data requires massive, ultra-sensitive radio antennas, and that's just to hear it. As we dream of even bolder missions to the Oort cloud or nearby stars, we'll need even more advanced communication tools like laser links or interstellar beacons that can stretch across the darkness. There's something else unique about Voyager's view: perspective. Unlike telescopes on Earth, which peer through layers of atmosphere, or even space telescopes that orbit close to home, Voyager 1 is truly untethered. It's drifting freely in interstellar space with nothing to block or distort what it sees. That distant, unobstructed viewpoint could offer valuable insight into the structure of the galaxy itself, helping us refine cosmic maps, detect faint signals, and better understand how the universe is stitched together. In short, Voyager 1 is more than a spacecraft. It's a scout, a scientist, and a storyteller, all rolled into one. And its journey is far from over. As Voyager 1 drifts farther into the deep unknown, it's not just chasing distance, it's uncovering hidden layers of the universe. Though its tools are aging and modest by today's standards, the spacecraft may still detect subtle ripples in space, gravitational or electromagnetic nudges from unseen giants like rogue planets, brown dwarfs, or faint undetected stars. A slight wobble here, a tiny drift there. Each could be a clue, pointing to massive objects that lie just beyond our sight. This isn't just a journey, it's a slow, profound conversation with the cosmos. Every signal Voyager sends is like a question thrown into the dark. What is space like when it's no longer shaped by the sun? What forces mold the particles and plasma drifting through the galactic void? How do invisible structures in deep space affect matter and energy? What began as a mission to study the outer planets is now mapping the hidden architecture of the galaxy itself. In fact, Voyager's instruments are acting like translators, picking up the cosmic language of vibrations, pulses, and electromagnetic whispers. As the probe moves deeper, it may even enter denser regions, perhaps brushing up against the edge of an ancient interstellar cloud. If it does, scientists will witness something unprecedented: how a spacecraft behaves in an environment no longer ruled by the sun, but by the forces of the galaxy itself. This could be a turning point. If Voyager detects new fields, energy patterns, or shifts in cosmic behavior, it could reveal how the interstellar medium has changed over time, how stars form, how matter from long-dead stars spreads, and how galaxies recycle and evolve. Each bit of data could help trace the life story of the Milky Way itself. Even more, Voyager is helping scientists understand how stable or unpredictable interstellar space really is. Does plasma density hold steady over time? Do magnetic fields ripple or roar with turbulence? Are high-energy particles scattered evenly, or do they travel in hidden rivers through space? Voyager 1 is now in a position to watch how these conditions change, not just across space, but across time. Its power won't last forever. Within the next decade, the spacecraft may fall silent, but until then, every bite it beams back is a treasure. These final years could lay the groundwork for a new age of exploration, one where we don't just aim for planets and stars, but pay attention to the vast, mysterious spaces between them. Because in that in-between, the real story of our galaxy may be waiting. Voyager 1 isn't just a spacecraft. It's a message in a bottle sent across the cosmic sea. It's proof of what we can achieve when human curiosity is unchained, when we dare to ask what lies beyond the edge of everything we know. Built with 1970s technology and powered by persistence, it continues to whisper back to us from the unknown. One of its latest revelations? A low, steady hum, an interstellar plasma wave that echoes like a faint song from the deep. It's one note in a vast cosmic symphony that Voyager 1 is slowly bringing into focus. And that music tells us something profound. Space isn't silent, and it's far from empty. It's full of energy, mystery, and movement, waiting to be heard. Now beyond the heliopause, the invisible border where our sun's influence fades, Voyager 1 is sailing through truly uncharted waters. This isn't a blank, lifeless void. It's a rich, dynamic environment shaped by billions of years of galactic evolution. Here, ancient supernova, magnetic storms, and atomic particles weave a story we're only beginning to understand. Even though it wasn't designed to study interstellar chemistry, Voyager 1 is helping to decode what the galaxy is made of. It detects subtle hints of hydrogen, helium, and traces of heavier elements like oxygen and iron, breadcrumbs left behind by stars that lived and died long before Earth ever formed. The very space it moves through is made of stellar ashes, material that could one day ignite new suns and build new worlds. And then there's the dust, tiny drifting specks that carry the ingredients of planets and possibly life. As Voyager glides through the interstellar medium, it's occasionally struck by microscopic grains. These tiny collisions are like fingerprints, revealing where the dust came from, how fast it's moving, and what it's made of. Some grains may have exploded out of nearby dying stars. Others could be ancient travelers from across the galaxy, shaped by unseen forces and bent by invisible fields. Each bit of data Voyager 1 sends home is like a postcard from the edge of forever. It shows us that the universe is not a static place. It's alive with forces, interactions, and secrets still waiting to be discovered. And through this lonely, resilient traveler, Earth remains connected to the farthest reaches of space. Voyager 1 isn't just sending back scientific gold, it's also offering something equally rare, a long-running, real-world test of how human-made materials survive the harshest environment imaginable. For nearly 50 years, this spacecraft has endured deep space's brutal cold, relentless radiation, and the constant strain of motion, far beyond Earth's protective bubble. And it's still working. That durability is more than impressive. It's a treasure trove of insight for engineers dreaming up the next generation of interstellar probes or robotic explorers meant for extreme worlds far from home. But Voyager's mission goes even deeper. As it coasts through interstellar space, it's no longer just following a straight path. Its journey is subtly shaped by the massive, invisible forces that structure our galaxy. Gravitational nudges from stars, swirling magnetic fields, and the quiet tug of the Milky Way's rotation. Voyager 1 is riding the currents of the galaxy itself. By tracking these shifts in motion over time, scientists are piecing together a new map of galactic dynamics. Its course provides hints about hidden matter, unseen gravitational anomalies, and even the potential fingerprints of dark matter, insights telescopes alone could never offer. And though Voyager 1 has escaped the Sun's direct grip, it still feels the long arm of solar activity. Occasionally, it picks up the faint remnants of solar storms, shock waves from eruptions that occurred years earlier. These waves race across space at incredible speeds, and the fact that Voyager still detects their fading signatures tells us that the Sun's reach goes far beyond where light dims or planets orbit. It's cosmic weather in slow motion, unfolding across time and space. These discoveries don't just help us understand our own solar system, they set the stage for understanding others. If our star leaves a detectable imprint billions of kilometers away, other stars might too. Voyager is helping define the true edges of a star's influence, not just in light or gravity, but in energy, motion, and magnetic touch. In its twilight years, Voyager 1 is still reshaping how we see the universe. It's not just drifting into the void, it's guiding us through it. One of Voyager 1's lesser-known but incredible roles is acting as a cosmic landmark. Floating far beyond the planets, it's become a stable, trusted point in deep space, a reference that astronomers can rely on. Scientists use its position and data to fine-tune models of planetary motion, calibrate space instruments, and double-check readings from Earth. It's like having a weather station at the edge of the solar system. When a burst of cosmic rays hits Earth and Voyager, one detects the same event moments, or even hours later. The comparison helps map how those particles travel and fade over billions of kilometers. In that way, Voyager isn't just a lonely spacecraft, it's part of a vast solar system-sized observatory. But its contribution goes even deeper. As Voyager sails through interstellar space, it's effectively moving through time. It encounters ancient phenomena, shock waves from exploded stars, magnetic fields shaped long before Earth was born, and radiation still echoing from cosmic events long past. Voyager 1 is like a space archaeologist, unearthing clues from the galaxy's deep history. Every bit of data it beams home is a message from an era we never saw but can still study. And then there's the unexpected beauty of its mission. Though we can't see the data it collects, we can translate it into sights and sounds, and the results are stunning. When plasma waves are turned into sound, for example, they produce haunting whistles and hums, like a ghostly melody echoing from the galactic frontier. These sounds aren't just for the imagination. They help scientists notice patterns and irregularities that graphs or charts might miss. Voyager's data doesn't just inform, it inspires, revealing that even in the vast silence of space, there's a strange and beautiful music playing.